Welcome back to my channel. So after we learn the differentiation of logarithm exponential function, now is the 8.5, which is differentiations of inverse trigonometric functions. So in here, we can just memorize the formula as previous, but I will tell you how to derive the formulas. So the first one we learn is y equals tangent inverse x. When we integrate this y equals tangent inverse x, we will get dy dx equals 1 over 1 plus x squared. So now I will tell you how to differentiate these things. So I will show you the step by step. Derivatives. So we have y equals tangent inverse x. So in order to cancel this tangent inverse x out, we add tangent to both sides. So we add tangent y equals to tangent inverse x. As we know, tangent and tangent inverse will cancel each other. So at the end, we will left tangent y equals to x. So now we are doing the implicit differentiation. I hope you all still remember implicit differentiation. Now we differentiate with respect to, here is with respect to WRT x. Alright, so that means we differentiate both sides with x. That means like that, d dx tangent y equals to d dx x. So we will get, as we know that tangent y, how we differentiate the tangent y? I will say that because here we got the x, but here we have the y. So as I said, d dx equals to d dy dot dy dx. So we can just d dy here, but we add the dy dx at the end. I hope you all still remember. So yeah, and hence we will get, we know that differentiate the tangent y will become secant square y. Then we times back the dy dx, since this is the x and this is y. So we add the dy dx at the end. So here we will get 1. So now we only want dy dx, so we move to add other things to the right hand side. So we get secant square y. However, we know that the function given is in x. So here is y. So how are we going to do it? I will tell you, here is a very interesting part. So we apply the Pythagoras theorem. I hope you all know this theorem. So yeah, let's say we have secant y, secant square y. It actually is equivalent to cos square y, right? Alright, so now we have something here. So we have y. Let's say this angle is y. It's according to here. So you know that from the equation given, which is tangent y equals to x, from here, so we know that tangent y equals to x. So what is tangent? You know that tangent y is x over 1. Here is an imaginary united one. And now x tangent we know is opposite over adjacent. So opposite here is O. So the O is actually is x, whereas the adjacent part is here. So adjacent is 1. So in using Pythagorean theorem, we can find the hypotenuse using the formula. We know here it's actually 1 squared plus x squared. So it's equals to square root 1 plus x squared. So now we have this direction really. So now by using this triangle, we implies that just now we put here. So dy dx equals to cos square y, and equivalence to cos y squared. And cos y, now we are finding the cos y. We know that cos y is actually adjacent or hypotenuse. So adjacent in this case is 1, whereas the hypotenuse is square root 1 plus x squared. But don't forget the square here, so we must square all things. We will get 1 over 1 plus x squared. So here's how we derive the differentiations of the inverse trigonometry for the tangent inverse x. Alright. So the second, I will share about this differentiation of the sine inverse x. So sine inverse x, when we dy dx, let's say y equals to sine inverse x, and dy dx we will get 1 over square root 1 minus x squared. So how are we going to do this? So it's the same theory only. So yeah, in order to cancel this sine inverse here, we add sine to both sides, so we get sine y equals to x. So in this one, we can draw a triangle using sine y equals to x. So the angle is y, let's say. So sine y, x over 1. So sine, is opposite over hypotenuse. So the opposite part is x, and the hypotenuse is 1. So we know here, by using the Pythagorean theorem, we know here is 1 minus x squared. Right. So now we just use back the same method. We differentiate with respect to x. Implicit differentiation, both sides we get here is sine y. We differentiate sine y, we get cos y, and times back a dy dx since we are differentiating with respect to x. So here, whereas here is equals to 1. So dy dx, I move to the right hand side, is 1 over cos y. So cos y, what is cos y? We based on this triangle, we want to find the cos. Cos is actually opposite, is adjacent over hypotenuse. So adjacent is 1 over square root 1 over x squared over 1. So we get 1 over square root 1 minus x squared. So here how we derive for the sine inverse x. So it's the same with the cos inverse x. Yeah. So yeah. So for the third, I will start with a new page. So third is the cos inverse x. When we differentiate it, you get dy dx equals to negative 1 over square root 1 minus x squared. You can try yourself, but I will tell you. You can pause the video and try yourself how to derive it. So yeah, it's the same thing. We just add cos on both sides, cos y equals to x. And here now we differentiating with respect to x, implicit differentiation of both sides with respect to x. So we know that cos y equals to x, and another triangle should be drawn. Cos, cos is adjacent or hypotenuse. So here is x, and hypotenuse is 1. So here is 1 minus x squared. Oh, I'm sorry, it's adjacent. Adjacent should be this part, right? Yeah, adjacent. Here is adjacent, and here is hypotenuse, and here is 1 square root 1 minus x squared by theorem Pythagoras. So now, how we differentiate it? So differentiate cos y, is sine y. But what I say is differentiate anything start with co, we will get a negative sign here. So because we are differentiating with respect to x, we add a dy dx at the end. And here we get 1, and dy dx equals to negative 1 over sine y. So from the triangle, we can find the sine y is actually, sine is opposite over hypotenuse, where opposite is square root 1 minus x squared, and here is 1, right? So we got the answer is here, 1 minus x squared. Alright. So, however, the correction in your syllabus won't be so easy and direct. So let's say I give an example. Y equals to sine inverse 2x. So, what is the dy dx? Okay, you can pause the video and try to solve it. Alright, so actually, I would say that in syllabus, everything's about differentiation. If you see something here, you put a bracket, it's chain rule. It is a chain rule. So now I tell you how to solve this. We let u equals to 2x, and du dx will equals to 2, and y equals to sine inverse u, and dy du. It implies the result we get just now. Dy du, it should be 1 over square root 1 minus x squared. So we replace the x with the u, so it's 1 minus u squared. So now dy dx equals to dy du times du dx. So we get 2 times 1 over square root 1 minus u squared, and we get 2, 1 minus 2, here is u squared. As we know that u is equivalent to 2x, so it's 2, 1 minus 2x squared, so we get 2, 1 minus 4x squared. So here is the answer, so you must see. So if you are in university level, they will given the formula as well, but however in SCPM they are not providing the formula, so we deduce the formula. You can just memorize summary. Deduce when we have y equals to tangent inverse ax plus b, where a and b are constant. Alright, so now deduce that dy dx will equivalent to a over 1 plus ax plus b squared. It's exactly the same as you can see here. Yeah. So we replace the x with something. However, this one is actually the f prime x. As you can see, yeah. Here, you try to know this is fx. Here is fx. And you differentiate this part, you differentiate the fx. You will get f prime x equals to a. So here is the summary. Yeah, here is the shortcut. You can just memorize this. And if y equals to sine inverse ax plus b, I hope you all understand really. So dy dx will equivalent to a. A is f prime x over square root 1 minus, here is the fx. So here is the f prime x, here is the fx, and here is the origin fx. Yes. And the third one, y equals to cos inverse ax plus b. Dy dx, anything start with co, you get a negative here, negative a over square root 1 minus ax plus b squared. Yes. That's all. Here is the fx, and here is the f prime x. Alright, so a little reminder that we, as the student times always confused, that is tangent inverse x is not equivalent to tangent x inverse. Here, this one is actually reciprocal. Reciprocal. Here is equivalent to 1 over tangent x. Yes, and they are not equal. Not equal. Alright. And tangent square x is equivalent to tangent x square. Here is correct. And here is not equal. And I would say f prime x is not equivalent to 1 over fx. This is definitely wrong concept. And f inverse x is not equivalent to the f inverse x to the power of negative 1. Here is wrong. And only this one is correct. Alright, I think here is the only videos, the video until here only. So the next video I will talk about the curve and the stationary point and general strategy how to solve the stationary point and yeah. Alright, here's thanks for watching.